Welcome to another Intermediate Algebra video. Today we continue our journey into graphing. We're going to look at another method we can use for graphing a linear equation. So our objectives for this video are to graph linear functions using intercepts, and graph vertical and horizontal lines. All right, so our first problem. So what we previously did to graph a linear equation like this was to come up with a set of random points. So remember that this f of x is the same thing as y. So this is just like saying y equals 2x plus 2. And we could choose some x's, find their corresponding y values, or vice versa, or a mixture of both. Let's say we plug in for x. Let's go with -1, 0, and 1. If we plug those in, we get y equals 2 times -1 plus 2, which is 0. So the ordered pair we have -1, 0. When we plug in 0, times 0, we get 2. And when we plug in 1, we get 4. So the ordered pairs we have that we can use to graph this linear equation are -1, 0, 0, 2, and 1, 4. Just to kind of tie everything back together, remember that if it's written with this notation f of x, then we already know that this is a function, so it means it would pass the vertical line test. And then we have these ordered pairs that we can use to graph. Oh, and it's a linear equation because when we write it with y and x, we have x to the first power, y to the first power. We could write this in the format ax plus by equals c. So we know we expect a line. Okay, so our three ordered pairs, let's get a quick sketch of a graph here. -1, 0, 0, 2, and 1, 4. Let's do this in red. -1, 0, 0, 2, and 1, 4. The 3 points are lining up, that's good. This is a linear, it should. And there's the graph of our line. So this is one of the methods we have for graphing a linear equation. We can find these random ordered pairs and then plot them. Another method is to use the intercepts. So here's our definition for x and y intercept. An x-intercept is, let's get a quick sketch of that line that we just had. 3, 4, 1. Oops. In red. 0, 2, 1, 4. So an x-intercept is a point that crosses or touches the x-axis, and you find this by plugging in 0 for y and solving for x. So your ordered pair will look something like this. In a linear equation, there's only going to be one of them. And then your y-intercept is the same, but for y. It crosses or touches the y-axis. To find it, you plug in 0 for x and then solve for y. And your ordered pair looks something like this, 0, comma, a number. So on the graph, what these are, your x-intercept crosses or touches the x-axis. Remember, this is the x-axis, so the x-intercept would be this ordered pair right here. And then your y-intercept crosses or touches the y-axis, which would be this point right here. So one strategy to graphing a linear equation is to find random points, plot them, connect. Another is to find the intercepts. Find the x-intercept, find the y-intercept, plot them, connect. For a linear equation, think about it, what's the minimum number of points you need to be able to graph that line? On the previous example, we used 3. Here, I'm saying 2. could you use 1? 1 wouldn't be enough information. If we had just this point, the line could go in any different direction from there. So we need 2 ordered pairs, and finding the x and y intercept is kind of a strategic way of finding 2 points. Plug in 0, solve. Plug in 0, solve. And you get the 2 ordered pairs. And 2 is all you need. All right, so let's graph using the intercepts. So here's an equation of function f of x equals 2x minus 4. And I know you might be looking at this and saying, well, I know a different way to graph it using the slope and the y-intercept. We'll get there, not yet. In this section, we're looking at using intercepts. Okay, so first let's find the x-intercept. An x-intercept crosses or touches the x-axis, so it means there is a left or right movement. There is not an up or down movement. That's why you plug in 0 for y and then solve for x. So we have 0 equals 2x minus 4. Solve for x. Add 4 to both sides. Divide by 2. We get x equals 2. The ordered pair for this x-intercept, 2, 0. Coming from plugging in 0 for y, solving for x. So there's one ordered pair, one intercept. Then define the y-intercept. A y-intercept is a point along the y-axis. So this is an up or down movement, and there's no left or right movement from the origin. So your x is 0, your y, something. Up or down, it's a number. So plug in 0 for x. We have y equals 2 times 0 minus 4. Y equals negative 4. The ordered pair here, 0, negative 4. We plugged in 0 for x. We solved and got negative 4 for y. Okay, so we have 2 ordered pairs. Plot them, connect, and we have graphed using intercepts. X and y axis. 1, 2, 3, 4. We'll graph in red again. So our first point, 2, 0. And then our second point, our y-intercept, 0, negative 4. We have 2 points. That's enough. Connect the arrows on the end, and we have the graph of this line using the intercepts. I often shorten x-intercept and y-intercept to x-int and y-int. You can do the same. X-intercept, y-intercept. And we've graphed this line. Okay. All right. Now let's look at graphing horizontal and vertical lines before we get to the practice. So this is our other objective for this section. These have very specific features, and you can't necessarily use the strategy of graphing with intercepts for these 2 specific types of lines. So let's look at both of them at the same time. Okay, so the first thing we want to graph is y equals negative 4. Think about that. This is linear because it's in this standard form of ax plus by equals c. It might not seem like it is, but remember that a, b, and c can be any number you want them to be. So it just so happens to be the case that for x equals negative 4, that this b value is 0. Which makes the y term disappear. And then the a value is 1, making it a 1x in front there. So this is a line. You can expect this to be a line. What does it look like? If x is equal to negative 4, imagine x is negative 4, 1, 2, 3, 4. Y, we don't have any information about y. Y can be anything. So here's a point. X is negative 4, y is 0. X is negative 4, y is 3. It doesn't matter what y is, you can make it anything. What matters, because based on our equation, is that x is -4. So here's a whole bunch of points. Well, for a line, all you need is 2 points. So connect them, and you have your linear equation. So an x equals a number line is a vertical line. Vertical line. Good. Okay, so if the x equals line is a vertical line, what do you expect the y equals line to look like? Vertical, horizontal. Y equals is a horizontal line. The number just tells you its exact placement for a y, up or down, for an x, left or right. So for our y, we have y equals 3. So that means x can be anything. X is 0, y is 3. X is 1, y is 3. X is 4, y is 3. X is -3, y is 3. All of these ordered pairs are valid. In this equation, the a value is 0, making this just by equals c, giving you just the y information. X can be anything, which gives us this horizontal line. These are special cases, and special cases that we can't use the intercepts for because they only cross one time. In both graphs, we're only crossing the axis, x or y, one time, and that's it. So these, you kind of just have to remember what they'll look like. Or go through the process. All right, if x equals -4, what do I know about y? Nothing, so y can be anything. And just kind of plot, and you'll get the line quickly. All right, so these are vertical and horizontal lines. Good. Let's do another example together. Let's graph y plus 5 equals 0. Change back. Okay, what do we do to graph this one? Is this a linear equation? Let's start there. If it's linear, we're going to be able to write it in this format, ax plus by equals c. And it definitely is. We can get the 5 on the other side. And then we have ax, which is 0x plus 1y equals -5. Now it's in that format, so this equation most definitely will be a linear equation. And once you solve for y, you can see kind of what you'll expect from this. If this is a y equals line, we have vertical or horizontal. Y equals from the last slide is a horizontal line. At the location, -5 for y. 1, 2, 3, 4, 5. This means x can be anything. 0, -5. 1, -5. -3, -5. I'm choosing random points because it doesn't matter what x is. All it matters is that y is -5. So this is a graph of this linear equation. Now the directions, if the directions just say graph, you choose what method you want to use. If they say use intercepts, then that's what you should do. You wouldn't be presented a question like this and asked to graph using intercepts because it's not really possible. You get one intercept, but that doesn't give you the line. Okay, and our last example, the kind of application side of it before you get to do a little practice. All right, so here's our given information. The cost of renting a car is modeled by the linear function c of x, let's highlight this, the function's always important, equals 0.5x plus 35, where c of x is in dollars and x is the number of miles. Then some questions. Find the cost of driving the car, 150 miles, and how many miles were driven if the cost was $50, then graph the function. Okay, so what's important when looking at a model, any sort of model, this one says linear, so we know it'll be a line, is to know what the variables represent. So let's note that. X is listed in the equation, listed not in the equation, in the sentence, in our given information. What does X represent? It says it at the very end of the line, X is the number of miles. Number of miles. And c of x, or you can write y, it's fine. What does that represent? Read through the equation, the sentence again. C of x is in dollars. So what do you think C of x is? If it's in dollars, it's the cost. And that's what the C stands for. Okay, so the first question, letter A, says find the cost of driving the car 150 miles. So to be able to answer that, you have to be able to plug in for one of the two variables and solve for the other one. Cost of driving the car 150 miles. So we are given information for x. Plug in for x, solve for C of x. C of x equals 0.5 times 150 plus 35. And then solve for C of x. Everything's on the right, it's all numbers, so we can just calculate this. 0.5 times 150, 75. And then 75 plus 35, 110. So the cost of driving the car 150 miles is $110. Okay, let's look at the second question. How many miles were driven if the cost was $50? So starting over, here's our model. We're given the cost of $50. So plug in for C of x and solve for x. Subtract 35 from both sides. Divide both sides by 0.5. We get x equals 30. So the answer, 30 miles. Okay, then the last question is graph the function. Graph the function. How can we graph this? Well, from A and B, we got two ordered pairs. For this one, we were given an x of 150, and we found the corresponding y value to be 110. For the second one, we were given a y value of 50 and solved for x and found 30. So we have two ordered pairs. All right, let's sketch this line down here. Now, the tick marks don't have to be every one unit. That's typically how we draw the graph, but you can make the tick marks whatever you want to. For this one, we have lots of jumps in 10, so I'm going to make each of them 10. Are you showing? Oh, we can't see. 10? Good. So 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So here's 150, and then our y's, again, go by tens. Cutting it a little bit, that's all right. Here's 110. Okay, then let's plot these two ordered pairs. So our two ordered pairs are 150, 110, and 30, 50. 2 points, connect, and that is enough information. Okay, so let's get a general idea of what this equation is saying. So this model is for the cost of renting a car. Now, I don't believe this is the way car rental companies rent their cars out, but I'm sure there's some sort of tiered system involved with this. So what this equation basically says is that you're paying $35 whether you drive the car or not. Whether you drive it 0 miles, 100 miles, 150, 1,000, 3,000, however many miles you drive it, you're basically making not a down payment, but you're paying $35 for the wear and tear that's going to happen to their car. And then you're also going to pay 0.5 times every mile that you drive. What do you think the 0.5 represents? 0.5 is the same as 0.50, which means 50 cents. So you're paying 50 cents per mile. So you're paying 50 cents per mile plus $35. You're paying $35 and then 50 cents for every mile that you drive. So this shows, based on the number of miles that you drive, how much you're going to pay for the car. And it doesn't quite intersect at the right spot. I mean, this is a graph drawn by hand, so it's never going to be perfect. But it should be going through right here. This is a little bit better. It should be going right through this point. That's one of the intercepts we have in this graph of 0, 35. We plug in 0 for x, we get 35 for y. And this says if you drive 0 miles with the car, you're still going to pay $35 to rent the car. Now, in any model, there's places where this makes sense and places that it doesn't make sense. For this one, somewhat not realistic for you to not drive any miles and pay $35 for the car. You could, I suppose, you could pay the amount and then sit in the parking lot and turn it back in. But it definitely doesn't make sense when we get into the negatives. So when we get into this side of the graph over here, when we get to the left side of the graph, we're saying we're driving negative miles and then paying money. Not going to happen. And eventually you're driving negative miles and negative money. So it becomes not realistic at a certain point. But you don't have to worry about that when it comes to graphing the function. Just start to think about those things. It'll help in your process to know that there's certain places that it doesn't make sense. It becomes, I'm not finding the right word for not realistic, but it becomes not so realistic as you get into these negative realms. So hold on to that. But the general idea is to just graph this function, which we have done. And if it says that, don't worry about those irrelevant places. Just graph the entire line. Okay. What do I have? 1? Okay, good. All right, go ahead and practice this. Pause the video. Graph this function using intercepts. This one should be done using intercepts. Don't use the first method. If the directions just said graph, the choice would be yours, but you might be asked to use each method of graphing individually. So for this one, go ahead and use the intercepts. X-intercept, Y-intercept, plot them, and you have your line. Okay, let's see how it went. So remember again that this equation can be looked at as y equals negative x minus 4. Then find the x-intercept and the y-intercept. If you found y first, doesn't matter. You just need to find them both. X-intercept means y is 0. You're on the x-axis, you're not moving up and down, so y is 0. Solve for x. I'm going to add x to both sides and get x equals negative 4. If you solved a different way, that's fine. You should still be getting x equals negative 4. So the ordered pair is negative 4, 0. Then our y-intercept, set x equal to 0. Negative 0 minus 4. Negative 0, it's just 0. 0 doesn't have positive negative orientation. We get negative 4. So this ordered pair, 0, negative 4. Good. All right, then let's put these together on the graph. I'm only making the tick marks for the ones I need, and these are all 1 unit apart. So we have negative 4, 0, and 0, negative 4. Oh, missed. Connect, and you have your line. So here is our graph done using intercepts. Graph this linear function using intercepts. All right, so that completes this video. In this video, we looked at our second method. We'll have 3 different ones. Our second method of graphing linear equations, which was using intercepts. And then we also looked at graphing horizontal and vertical lines.